Hello and welcome once again in this MOOC course on control system. In previous class, we have discussed the effect of feedback on stability of the system and gain of the system. In today's class, we will discuss the effect of feedback on sensitivity. This sensitivity is very useful term to assess the performance of control system in changing environment. This is very useful term to assess the performance of control system in changing environment. Actually, what will happen in changing environment? Because of this changing environment, one of the parameters may change. Say for example, forward path transfer function may change, or feedback path transfer function parameters may change. So because of changes in such parameters, one of the variable, suppose output of the system may also change. So we have to find the changes in corresponding output variable because of parameter variations, transfer function, forward path transfer function, and feedback path transfer function. Then we will find the sensitivity of the system. So we will start today's class with the topic effect of parameter variations. Suppose this is forward path transfer function we are considering at the moment. We are considering the variations in forward path transfer function. In case of open loop control system and closed loop control system. Once again, I repeat, in today's class, we will discuss the effect of feedback on sensitivity. So this sensitivity is very useful term to assess the performance of a control system in changing environment. Because of changing environments, one of the parameters, say for example, GS, that is forward path transfer function, or HS, that is feedback path transfer function, may change. This may cause the changes in variables, say for example, in output. So we will find out the effect of parameter variations in case of transfer function, forward path transfer function, considering open loop and closed loop. And finally, we will find the sensitivity. So first case I will discuss, that is effect of parameter variations in case of open loop control system. In open loop control system, input is RS, standard input to reference input is RS. This is GS, and finally we have output CS. So these two relationship between input and output is related by the transfer function, or RS is cos. RS is cos which produces the effect CS, that is the output. So for this closed open loop control system, overall transfer function is output upon input. That is Laplace transform of output, ratio of Laplace transform of output to the input, that is the RS in Laplace transform form. This is basically GS. In case of open loop control system, overall transfer function is equal to forward part transfer function GS. That is the ratio of CS to RS. And suppose there is variation in forward part transfer function, that is GS. And suppose because of noisy environment or because of changing environment, GS changes by slight value, that is delta GS. So this delta GS is slight change in GS. This is the slight change observed in forward part transfer function because of changing environment. And because of this change, variable output CS is also changed by an amount delta CS. So this CS is change in output. This is change in output. Now we will find the value of delta CS. So output CS for this control system, that is open loop control system, is CS is equal to RS into RS into GS. This variation in transfer function causes the output CS to change by an amount delta CS. So this way, this is RS, and change in forward part transfer function is GS plus delta GS. So previous value of GS is now modified by this slight change delta GS, and because of this change, output variable is also changed by an amount of delta CS. So this CS plus delta CS is equal to, this is RS into GS plus RS into delta GS. This CS is basically RS into GS. So these two terms will be cancelled out. So changes in variable CS is equal to delta CS, that is RS into delta GS. RS into delta GS. So because of parameter variation, that is forward part transfer function in this case, which is slightly changed by an amount delta GS, we have corresponding change in output variable, that is given by delta CS is equal to RS into delta GS in case of open loop control system. Obviously, feedback will reduce the effect of these variation. So in next derivation, we will find how the feedback is useful to reduce such variations. So in second case, we will consider the closed loop control system, which is given by this diagrammatic representation. Input is RS, and we are taking negative feedback system. So this is minus, this is plus, this is comparator, this is transfer function GS, forward part transfer function. Output is once again CS. Output is sampled in case of feedback path elements having the feedback path transfer function, that is HS. So this is the closed loop control system. In similar manner, we will find the overall transfer function. We have already derived the relation for closed loop control system, particularly in negative feedback. This, because of this minus sign, it is recognized as negative feedback. This is given by GS upon 1 plus GS HS. This is the overall transfer function for control closed loop control system. This is basically ratio of output quantity CS and input quantity RS. Again, we are taking the effect of parameter variations. So this GS is GS plus delta GS because of parameter variations. So this delta GS is slight change in GS. So this will cause to change the output CS by the amount CS plus delta CS. This is the changes observed in output when forward part transfer function GS has been slightly changed by an amount delta GS. So in this case, we will find the value of changes in output variable, that is delta CS. So this relation, from this relation, we can write down this CS is equal to GS upon 1 plus GS HS, and this is multiplied with RS from this relation. Suppose this is equation number 1. This is equation number 1, which can be written in this way. So this CS, now output is changed by an amount of delta CS because of change in this parameter GS, which is GS plus delta GS. So we have this relation 1 plus HS into GS plus delta GS multiplied with input RS. Procedure is very similar to open loop case. Only difference is that in closed loop control system, overall transfer function MS, which is the ratio of output quantity CS to input quantity RS, is given by GS upon 1 plus GS HS. This is equation number 1. From this equation number 1, we have written this CS in this way. Now GS is changed by this amount. So this will cause the output to change by this amount. So net output is CS plus delta CS. GS is basically parameter, and this parameter is causing to change the variable output CS. So if we consider here that this delta GS, this is slight change in GS, is very smaller as compared to forward part transfer function GS, then this delta GS is very less than the forward part transfer function GS, then it is possible to write down the equation in this way: CS plus delta CS is equal to GS plus delta GS. This is 1 plus GS HS plus delta GS into HS. This is RS, input multiplied by input. This term can be neglected as compared to 1 plus GS HS. This term, second term delta GS HS, can be neglected as compared to 1 plus GS HS. So finally we have CS plus delta CS is equal to RS GS upon 1 plus GS HS plus delta GS RS. This is 1 plus GS HS. This first term is nothing but it is basically, this is approximated. Actually we have neglected this thing, so this CS is basically equal to this. So these two terms will be cancelled out. So finally we have delta CS, that is change in output in closed loop control system because of forward part transfer parameter variation. This is equal to delta GS into RS. This is 1 plus GS HS. This is 1 plus GS HS. So this is the corresponding changes in the output if forward part transfer function GS is changed by this amount. So this is the relation in case of closed loop control system. So this numerator is divided by this 1 plus GS HS. So obviously in case of closed loop control system, the changes is less as compared to open loop control system, because in open loop control system delta CS is equal to delta GS multiplied with RS. This is in open loop case, and this is the output in closed loop case. So variations in closed loop control system is less than as compared to open loop control system, which is given by this value, which is given by this relation. So if this is equation number 2, say for example, this is equation number 3, we can compare and conclude that effect of feedback reduces the variations by this amount 1 plus GS HS as compared to open loop control system. Now we can define the term sensitivity. We can now define the term sensitivity in these two cases. In case of open loop and closed loop control system, GS parameter variation takes place in this GS. This is parameter. Because of this parameter, output variable, this is output variable, changes its value. Parameter which changes its value because of environment conditions, and changes takes place in variable that is output variable CS. So we can define the term sensitivity in this way. sensitivity, this as denoted by S, this is sensitivity. This is percentage change in output C because of parameter variation in forward, because of changes in parameter forward part transfer function. So this is percentage change in G, which can be further written in this way. This is delta C upon C divided by delta G upon G. So this is the sensitivity. This is the sensitivity. So this is in mathematical term, sensitivity is written in this way. This denotes sensitivity of variable C with respect to parameter C. This is the sensitivity of variable C with respect to parameter C, and this should be minimum, and this parameter should be minimum. This parameter should be minimum. Sensitivity should be minimum. So we have discussed the case of open loop and closed loop control system, considering the changes in forward part transfer function, which causes the change in output variable, and we have defined the term the sensitivity. That sensitivity is the useful term to assess the performance of control system when conditions are changing, when there is changes in environment in which system is operating. So we can assess the performance by this useful term sensitivity, which is defined in this way, which is mathematically represented by this. So in next class, we will find the sensitivity of overall transfer function with respect to feedback part transfer function and forward part transfer function. So see you in next class. Thank you very much.